In this lesson, we're going to learn how to solve quadratics by factoring. In order to solve a quadratic, we have to use what's called the zero product property. The zero product property states that if the product of two or more factors is equal to 0, then at least one factor must be equal to 0. So in other words, if we say that a times b equals 0, that means that either a could be 0 or b can be 0. The only way a product can equal 0 is if one of them equals 0. So looking at the first example, these quadratics are already factored and we're just going to solve. So if we're saying that something times something equals 0, then what we do in order to solve is we set the first product equal to 0 and then the second product equal to 0. And then we would just solve. So in this case, we would add 4 to both sides. That means x equals 4. And then same thing here, but we would subtract 5 from both sides. X would equal negative 5. So for these problems, we're used to solutions only, there only being one solution, but since we're dealing with quadratics, x squared, then we are going to have up to 2 solutions. So looking at example 2, kind of the same idea. We have a product. In order to solve, we're going to set each factor equal to 0. So the first one would just be x equals 0, and that's already solved. The second one, we would say x plus 6 equals 0. To solve, we would subtract 6. So x would be negative 6. So my 2 solutions would be x equals negative 6 and x equals 0. So we could go back and check our answers. If we plug in 0 to this equation, it'd be 0 times 0 plus 6. So 0 times 6 would equal 0. And then there should be another solution, which is x equals negative 6. We plug in negative 6 for x. It would be negative 6 times negative 6 plus 6. If this equals 0, it would just be negative 6 times 0, which equals 0. So there's 2 solutions. There's 2 things that would make this true. Looking at the last example, same idea. We have a product, and we know that that product is equal to 0. So we're going to set each factor equal to 0 and solve. So this one we're going to subtract 5, so 2x equals negative 5, and then we're going to divide by 2. So I'm just going to leave it as a fraction, so negative 5 halves would be one solution. And the second one, subtract 5, so 3x equals negative 5, and then we would divide by whatever's in front of x, divide by 3. So again, I have 2 solutions. So now we're going to look at examples where it's not already factored. We have to factor it first. So here's a step-by-step. It says the solutions to a quadratic equation are called roots. The roots indicate where the quadratic equation crosses the x-axis. So when we learn to graph these, what we're going to see is we're going to have a quadratic, and a quadratic graphs as a parabola. The x-intercepts are the solution. So we'll talk more about that in the next unit. So the first example, it says calculate the roots for the quadratic equation. So what we're going to do is we're going to solve. So the first step, in order to solve a quadratic by factoring, we need to get one side equal to 0. So our equation is x squared minus 4x equals negative 3. If I want one side to equal 0, I'm going to add 3 to both sides. And then we're going to write it in standard form. So in this case, since these are not like terms, we can't combine them. So it's going to be x squared minus 4x plus 3. And negative 3 plus 3 is 0. So we need to make sure we write in standard form. All right, the next step is we are going to factor the quadratic expression. And in order to factor, we're going to go straight to our box. Okay, the quadratic goes across the diagonal, so x squared minus 4x plus 3. And then using our x, a times c, 3 times 1 is 3, and then negative 4. Since we are multiplying to make a positive number and adding to make a negative, that means both my numbers have to be negative. So I'm going to list out my factors of 3, and it's only 1 and 3. And since those add to 4, we're good. So negative 1x and negative 3x. And then we get the outside. So looking at the top row here, x squared and negative 3x, they have an x in common. So x times x gives me x squared. X times negative 3 gives me negative 3x. And x times negative 1 gives me negative 1x. So now I have my factors. It's x minus 3 and x minus 1. And we know that that's equal to 0. In step 3, we're going to use zero product property just like we did in the previous page. So we're going to set each factor equal to 0. So x minus 3 equals 0 and x minus 1 equals 0. And now we solve for x. So add 3. So x equals positive 3. And then for this one, we're going to add 1. So x equals positive 1. All right, once we have our solutions, we should check our answer by plugging into the original equation. So remember, our original equation is x squared minus 4x equals negative 3. So now that we have our solution, we're just going to plug in 3 for x, and we're going to plug in 1 for x and see if we end up with a true statement. So 3 squared minus 4 times 3, that should equal negative 3. So this is 9 minus 12 equals negative 3, and 9 minus 12 is negative 3. So since we end up with a true statement, we know that that is a solution, and now we're going to plug in 1. 1 squared minus 4 times 1, that should equal negative 3. So again, we have 1 squared is 1, and 4 times 1 is 4. And 1 minus 4 is negative 3. So again, I end up with a true statement, so we know that our solution is correct. All right, now let's take a look at the U-tries. So starting with number 1, first thing we need to do, so since one side already equals 0, we can skip step 1 and we can go straight into step 2. We're going to factor the quadratic expression. So to factor, first thing we need to do is look for a GCF. So I'm looking at 3, 24, and 36. It looks like my GCF is going to be 3. So I'm going to factor out my GCF first. So then we have 3, and then we have x squared minus 8x plus 12 is equal to 0. And now since we have a quadratic left over, we're going to factor it more. So I'm going to make my box. My quadratic goes across the diagonal. Okay, and then I'm going to, we're multiplying to make 2. Oops, sorry, 36 divided by 3 is 12, not 2. Since we're multiplying to make 12 and adding to make negative 8, I know that both my factors must be negative. So now we're going to list out my factors of 12, and I'm going to do it up here. So that 1 and 12, 2 and 6, and 3 and 4. So we're looking for the pair that add to make negative 8, and that's going to be 2 and 6. So then we have negative 2x here and negative 6x. And then we're going to get our outside. So the top row, x squared and negative 6x, have an x in common. Then this has to be x, then negative 6, and then we have negative 2. So factored, this is 3, x minus 6, and x minus 2. Don't forget your GCF out in front. Now once it's factored, we're going to use zero product property. So in this case, we know that 3 can equal 0 because 3 is just 3. So we're basically going to ignore the 3, and we're just going to set these factors equal to 0. So x minus 6 equals 0, and x minus 2 equals 0. Solving, add 6. So x equals positive 6. And then same thing here, we're going to add 2. So x equals positive 2. Once you have your solutions, you should plug them back into the original equation just to make sure that they work. All right, problem number 2. First thing we're going to do is we're going to check for GCF. In this case, since 3 and 7 are both prime, there is no GCF, so now we're going to go straight to our box. So 3x squared minus 22x plus 7. I'm going to do my factoring work off to the right-hand side. So we're multiplying to make 3 times 7, which is 21, and we're adding to make negative 22. And since we're multiplying to make a positive, adding to make a negative, that means both of my factors must be negative. So now we're going to list out my factors of 21. So 1 and 21 and 3 and 7. So the pair that's going to get us a negative 22 is going to be 1 and 21. Before we put it in the box, we should just double check that these multiply to make 21, they add to make negative 22, which they do. So now it goes straight into the box. So this is negative 1x and negative 21x. Now to get the outside, we look at our top row and take the GCF. So 3x squared minus 1x, all they have in common is an x, and then we can work backwards. So x times what gives me 3x squared? That's going to be 3x. X times negative 1 would give us negative 1x. And then 3x times negative 7 would give us negative 21x. So now I have my factors. So 3x minus 1 times x minus 7 equals 0. And to solve, we just set each one equal to 0 using zero product property. So 3x minus 1 equals 0, and x minus 7 equals 0. So to solve, I'm going to add 1. So 3x equals 1, and then divide by 3. So x is equal to 1/3. And then the second problem, to solve, I'm just going to add 7. So then I get x equals 7, and x is by itself, so I have my second solution. All right, number 3, I have x squared minus 5x equals 13x minus 81. So in order to solve this, we need one side to equal 0. It's easiest to move things to the x squared side because we want to keep our x squared positive. So I'm going to subtract 13x and add 81. So I got to do the opposite. Okay, now combining like terms, I'm going to start with my x squared, and then I have my x terms. So negative 13x and negative 5x is negative 18x. And then I have plus 81 equals 0. And once I have one side equal to 0, we're going to solve, or sorry, we're going to factor. So here's my box. Quadratic across the diagonal since there's no GCF. Okay, and just like before, I'm going to do my factoring work over here. So we're multiplying to make 81, and we are adding to make negative 18. So listing out my we're multiplying to make a positive, adding to make a negative, which means, again, both my numbers have to be negative. So first we're going to list out our factors, 1 and 81, 3 and 27, and then the only other factor should be 9 and 9. So if we're adding to make negative 18, it's got to be 9 and 9. So double check before we put in the box. Negative 9 times negative 9 is 81, and negative 9 plus negative 9 equals negative 18. So now I have my two factors. This is negative 9x, negative 9x. To get the outside, this is going to be x, and then we can work backwards. So my factors are x minus 9 equals 0. So now we're going to set each factor equal to 0. Well, in this case, since my factors are identical, I really just need to set one of them equal to 0, because we would get the same solution. So x would equal 9. And we actually end up calling this a double root when it's the same number. All right, we have one last example here, number 4. So first thing I'm going to do is subtract 13x to get one side equal to 0. So written in standard form, we have 6x squared minus 13x plus 5 equals 0. Now we're going to factor, so checking for a GCF. So 6, 13, and 5, there's no GCF. So now we're going to go straight to our box. So across the diagonal, we have 6x squared, negative 13x plus 5. And we're multiplying AC, so 5 times 6 is 30. And we're adding to make negative 13. So just like all the examples, we're multiplying to make a positive number, adding to make a negative, which means both my numbers must be negative. And now we're going to list out our factors of 30. 1 and 30, 2 and 15, 3 and 10, and 5 and 6 are my factors. So we're looking for the pair that gives us 13, and that's going to be 3 and 10. So negative 3 times negative 10 is positive 30. Negative 3 plus negative 10 is negative 13. So now we have our numbers inside the box. So negative 3x and negative 10x. And then we look at the top row and we take the GCF. So to get the outside number, we look at the GCF of 6x squared and negative 3x. So in that case, it's going to be 3x, and then we work backwards. So 3x times what gives us 6x squared? That's going to be 2x. 3x times what gives me negative 3x? That's negative 1. 2x times something gives me negative 10x, so that's going to be negative 5. All right, so now I have my factors. So it's going to be 2x minus 1 and 3x minus 5. That's equal to 0. Now we're going to use zero product property. So 2x minus 1 equals 0, and 3x minus 5 equals 0. So to solve, add 1. So 2x equals 1, and then divide by 2. So x is 1/2. And then to get my second one, we're going to do the same thing. So add 5. So 3x equals 5, and then we're going to divide by 3. So x equals 5 over 3. All right, now I'm going to go over a couple of the practice problems. So starting with number 3. This one is already factored, so we don't have to factor it. All we need to do is use zero product property. So we're just going to set this one, x plus 5 equal to 0, and 3x minus 1 equals 0. And then we're just going to solve. So subtract 5. So x equals negative 5 is one answer. And then this one, we're going to add 1, and then divide by 3. So x is equal to 1/3. All right, now we're going to do number 7. So first thing we need to do is we need to get one side equal to 0, so I'm going to subtract 4. So then we have r squared plus 3r minus 4 equals 0. And then we're going to factor. So since this is a quadratic, I'm going to use my box. R squared plus 3r minus 4 goes across the diagonal. And we're multiplying to make negative 4, adding to make 3, which means one has to be positive, the other has to be negative. Listing out my factors of 4 is 1 and 4 and 2 and 2. And the one that we can use to make 3 is 1 and 4. And in this case, it's going to be 4 minus 1, which means that the 1 is negative and the 4 is positive. So then this is 4r, this is negative 1r, and then we get the outside. So starting with the top row, r squared and 4r, GCF is r, and then we can work backwards. So this is r plus 4 and negative 1. So now it's factored. Now to solve, we just set each one equal to 0. And then we can solve. So minus 4 from both sides. So r equals negative 4. This one, add 1 to both sides. So r is equal to 1. All right, now we're going to do number 9. So looking at 9, first thing we're going to do is look for a GCF. And in this case, there is no GCF. So we're going to go straight into the box. So this is 8x squared minus 53x plus 30. And then we're going to use our x, so we're going to multiply a times c. So this is 240, and this is going to be negative 53. All right, so now since we're multiplying to make a positive number and adding to make a negative, that means they both have to be negative. Now I'm going to list out my factor pairs of 240. So I think there's going to be a lot. 1 and 240, 2 and 120, 3 and 80, 4 and 60, 5 and 48, 6 and 40. 8 and 30. 10 and 24. 12 and 20. And 15 and 16. Okay, so looking at our list, we're looking for the pair that adds to make negative 53. And in that case, it's going to be 5 and 48. Sorry, my dogs are growling. 5 and 48. So 48 plus 5 is 50. 48 plus 5 is 53, and 5 times 48 is 240. So this is negative 5x. And this is negative 48x. And now we can get the outside. So starting with the top row, 8x squared and negative 48x is 8x. And then we can work backwards. So 8x times x. 8x times negative 6 would give us negative 48. And x times negative 5 would give us negative 5x. So now I have my factors. X minus 6. 8x minus 5 equals 0. Now we can use zero product property. So x minus 6 equals 0, and 8x minus 5 equals 0. So to solve, we're going to add 6 to both sides. So x equals 6. In this case, we're going to add 5, and then divide by 8. So x equals 5/8. All right, last one we're going to do is number 13. So first thing we need to do is we need one side to equal 0. So I'm going to move these two terms to the left-hand side. So then we have 7k squared minus 23k minus 20. So we're just combining like terms, so the negative 14 and the negative 6 makes negative 20. And now we're going to factor, so checking for a GCF, there is no GCF, so we're going to go straight to the box. So 7k squared minus 23k and minus 20. We're going to multiply AC, so this is negative 140, and we're adding to make negative 23. Since 20 times 7 is negative 140. Since we're multiplying to make a negative number, that means one has to be positive, the other has to be negative. So now we're going to list out our factors of 140. So it's going to be 1 and 140, 2 and 70, 4 and 35, 5 and 28, 7 and 20, 10 and 14, and that's it. So now, since one's positive, one's negative, we're really looking for the pair that subtracts to make 23, and that's going to be 5 and 28. So 5 minus 28 is negative 23, which means 28 needs to be negative. The 5 would need to be positive. So now we have our pair. So this is 5k and negative 28k. And now we can get the outside. So looking at the top row, 7k squared and negative 28k, I could factor out a 7k. And then working backwards, this would have to be k, this is negative 4, and this is positive 5. So now we have our factors, k minus 4 times 7k plus 5 equals 0. And now using zero product property. So k minus 4 equals 0, and 7k plus 5 equals 0. So add 4, k equals 4. This one subtract 5, so 7k equals negative 5, and then divide by 7. So then k equals negative 5 over 7.